Hello and welcome back to EduNext Academy. I am Maani and today let us discuss about very different mathematics that is very interesting also regarding complex number or algebra of complex number. We might have done various kinds of mathematical operation on natural number or any whole number. But do you know what is complex number? Complex number is a very special kind of number. Actually, in the nature, complex number is present. Means Z. If we consider Z is a complex number, then it is a combination of real part and imaginary part, right? So, algebra of complex number deals with operation performed on complex number. Okay, that algebra operations are addition, subtraction, multiplication, division, and complex conjugate and modulus. Okay, so before going to individual operation, let us know what is complex number. A complex number imaginary part. Okay, so let Z be a complex number. It can be written as x plus I y. Here, this x is a real part, y is an imaginary part, and this I is imaginary unit. Okay, imaginary unit. You need to remember that this J is a complex number. It is a combination of real part plus imaginary part. As imaginary, that's why I have written I here. I is a imaginary unit. Y is a imaginary part. X is a real part. Okay. Now let Z is 3 plus I 4. So which one is real part? The 3 is real part or real number. 4 is imaginary number and I is imaginary unit. Right? But you can ask me questions, what is I? Or you can have a doubt, what is I? This I, an imaginary unit, can be derived in square root of minus 1. Okay, that means if you square I, it becomes minus 1. These two things you need to remember. Now, after knowing this, let us do some mathematical operation. First is addition operation. For addition operation, we are recurring to complex number. So let Z1 is one complex number, Z2 another complex number. So Z is equal to Z1 plus Z2. It's a simple addition. Then how we will do? Imaginary part, real part, they get together. How? Let's see. Let Z1 is equal to x1 plus I y1. Z2 is equal to x2 plus I y2. And if we add these two, that means x1 plus I y1 plus x2 plus I y2. Real part you combine together. That means it will be real part, take the real part together, x1 plus x2. Then plus I y1 plus I y2. This also can be written as x1 plus x2 plus I take common outside y1 plus y2. This is the addition operation. Okay. Now, if you subtract, that means subtraction operation. For subtraction, what happened? In place of plus, I will write minus. In place of plus, I will write minus. Okay, everything is same. This is minus. Okay, if you open this minus, it will be x1 plus iy1 minus x2 minus iy2. Now take real number together, that means x1 minus x2, iy1 iy2, take I outside, so it will be if I take that means y1 minus y2. This is how I can do subtraction operation. Right? Very simple. You need to explain the equation. Next come to multiplication operation. Third one is multiplication operation. How to perform this multiplication operation? So similarly, let z1 is x1 plus iy1, z2 is x2 plus iy2, then z1 into z2. What is that? Now x1 plus iy1 whole into x2 plus iy2. Now individually you multiply x1 x2 plus x1 I x1 y2. Similarly, I y1 x2 plus I into I, that is I square, that means minus square, this I square is equal to minus 1. Directly I am writing minus y1 into y2. Okay. Now after solving, take real part together, that means x1 plus x2, x1 x2 minus y1 y2. Okay, then plus take I common outside, x1 y2 plus y1 x2. Now in this way we can do multiplication operation. Right? Now let us do subtraction operation. How we are doing? Let's see. Division operation. Sorry. Next is division operation. That means z1 by z2. That means x1 plus I y1 divided by x2 plus I y2. Now here what happened? To neglect this, we have to multiply the complex conjugate of the denominator. That means this is numerator, this is denominator. Now here let's see, x2 plus iy2 is in denominator. We have to write the complex conjugate, multiply the complex conjugate both sides. This is the process. Okay. Now x1 plus iy1 in denominator, x2 plus iy2 is present. We have to write the complex conjugate of this. That means we have to multiply x2, the complex conjugate of iy2 is equal to minus iy2. Whenever we multiply this x2 minus iy2, the same thing also we have to multiply here, x2 minus y2. Now see, this is cancelled out. This is equal to this. So in this way, we can simplify the division operation. Okay. Now let us individually multiply a plus b, a minus b whole into, that means a square minus b square. So that will be here x1 plus I. Let us multiply together x1 x2 plus x1 iy2. This is minus because this one minus plus x2 I y1 and minus I into y, that is minus I square minus 1 minus 1 and minus 1, that is plus y1 into y2 divided by a square means x2 square minus b square. B square means I square that is plus y square, because this I square and this I into I, this is I square means minus 1. So minus into minus, that is plus. So obviously that will be x square plus y square, right? So now see, you need to simplify this. Okay, you need to simplify this. Then here the main thing is, this is this particular thing, that means x2 square plus y2 square should not be equal to 0. In this way, your division operation can be performed. Again I am repeating. Z1 by Z2 is division operation. Z1 is x1 plus iy1 divided by x2 plus iy2. Now see the denominator, write the complex conjugate of denominator. Now denominator is x2 plus iy2. Here I write x2 plus iy2. The complex conjugate of x2 plus iy2 is x2 minus iy2. The same thing I have to multiply in the numerator. Now see, this particular thing is coming in the form of a minus b whole into a plus b. A square minus b square. So here a is x2 means x2 square minus y2 square, but as I is present, so I into I, that is I square, that is minus 1. So minus that minus 1 and minus 1, that becomes plus. That means x2 square plus y2 square. And simply you need to simplify this. Means you take this together. Okay, I common, that means if you take I common, it becomes x2 y1 minus y1 x1 y2. So it becomes very simple. Now again I am simplifying. Now see, if I take this, after this, that means the numerator will be x1 x2 plus y1 y2, right? And if I take I common, means plus I common, this will come x2 y1 minus x1 y2 divided by x2 square plus y2 square. This is the final answer. This is one of the example I have solved. So according to your example, according to your test, you have to solve in this way. Now let us solve another one, that is your complex and modulus. Complex conjugate and modulus. This is very important operation. For complex conjugate means if Z is a complex number, then Z bar is complex conjugate. Okay, that means if Z is equal to x plus iy, then Z inverse will be x minus iy. Okay, now this is complex conjugate. Now if you do modulus, means mod of Z, okay, that will be x square plus y square square root over. Okay, this is how complex conjugate and modulus is defined. Modulus means mod, means the positive part, means the real part square plus imaginary part square root over, right? So now it is a positive part. Remember this. Mod means whatever may be coming, you have to make. Mod means you have to do modulus, means the finally you have to consider the positive one. Now complex means whatever the complex number is there, you have to just change the sign of imaginary part. I am just changing the sign of imaginary part before imaginary part, means here iy is the imaginary part, plus sign is there. So complex conjugate means I have to change the sign. If, for example, if Z is equal to x minus iy, then the complex conjugate of z will be x plus iy. I hope you understand this. Now this is a very introduction part of complex number. In my next video, we will solve different types of complex algebra of complex numbers. Simultaneously, we will discuss what are the questions are coming or expected questions that may come in your JEE Advanced or in JEE Main. Please stay with us and please don't forget to like, share and subscribe if you are new to this. If you don't subscribe, my next video will not be notified you. And thank you for watching.